In the rapidly evolving landscape of information technology, the integration of generative artificial intelligence is becoming increasingly essential. Generative AI, a branch of artificial intelligence, is responsible for generating content like text, images, and even code that is often indistinguishable from that created by humans. In this course, I'll work to provide IT professionals with the knowledge and practical skills to leverage generative AI in the field of IT administration. I'll begin by exploring generative AI concepts and tools. You'll learn how to deploy generative AI models and apply generative AI techniques on Azure. I'll then investigate how to create effective prompts and how to integrate your organization's data with Azure OpenAI models. Next, I'll focus on analyzing generative AI models, automating tasks, and integrating generative AI tools. Finally, I'll cover security concerns with using generative AI, explore how to apply security protocols, and how to troubleshoot generative AI. This video explores generative AI fundamentals and concepts, including how they can be applied on the Azure Cloud Platform. Generative AI does not rely on magic. Rather, it harnesses mathematical techniques that have evolved and improved. In this video, we'll explore large language models, generative AI, Azure OpenAI, copilots, and prompt engineering. Okay, let's start with large language models. So generative AI relies on large language models, which are specialized machine learning models for natural language processing tasks. Although the mathematical concepts behind large language models can be quite complex, some basic ideas behind their architecture provides insights into how they work. Let's discuss transformer models. So these are the cornerstone models of modern natural language processing in machine learning. These models are trained on large, massive volumes of text, and they capture semantic relationships between words, which is one reason why they can generate text that closely resembles human responses. Transformer architecture comprises two main blocks, encoder and decoder. The encoder creates semantic representations of the training vocabulary. The decoder generates new language sequences. Notable implementations of transformer models include bidirectional encoder representations from transformers, or BERT, which is Google, and this has an encoder only, and generative pre-trained transformer, or GPT models from OpenAI, and these have the decoder only. Okay, so the initial step when training a transformer model involves tokenizing the training text. Tokenization is the process of decomposing the training text into individual units that represent unique text values like words, partial words, combination of words, and punctuation. This makes it possible for machine learning models to analyze or process the text. With an adequately large training data set, the model can acquire a vocabulary of thousands of tokens. Okay, so now let's look a little bit further at tokenization. So to keep it simple, we can just think of each distinct word in the training text as a token. Although in practice, tokens may be generated for words, partial words, combination of words, as well as punctuation. So for example, consider this sentence: I saw a cat chase a mouse. To tokenize this text, each discrete word can be identified and assigned a token ID. For example, I can be provided with a token ID of 1, saw with 2, 3, cat 4, chase 5, again would be 3 because is already tokenized as 3, and then mouse, and that token ID would be 6. So the sentence can be represented with the tokens 1, 2, 3, 4, 5, 3, 6. As model training continues, each new token in the training text is added to the vocabulary with appropriate token IDs. So for example, under would be 7, again 3, and barn would be 8. So the sentence overall can now be represented with the tokens 1, 2, 3, 4, 5, 3, 6, 7, 3, 8. All right, now embeddings. Although we can conveniently express tokens as simple IDs, it doesn't say anything regarding the meaning of the words, nor does it say anything about the relationship between them. To establish a suitable vocabulary to capture the semantic connections amongst tokens, we establish contextual vectors, or embeddings. Embeddings are numerical representations with multiple values, for example, 9, 2, 3, where each numeric component signifies a distinct characteristic of the information. In the context of language tokens, every element within a token's vector encodes a specific semantic attribute. The precise categorizing of these vector elements in a language model evolves during training, and the values are driven by how frequently words are used together or how they are used in similar contexts. Okay, now for this, we can represent the tokens in the sentence "I saw a cat chase a mouse" as multi-dimensional vectors where each dimension represents a specific aspect of the token. In this example, each dimension represents a different semantic aspect of the tokens, and tokens with similar meanings or contexts tend to have similar vector representations. Just take a look at the two A's representing "I saw a cat chase a mouse." They're identical. From a graphical representation, the location of the tokens is suggestive of how closely related the tokens are. Real language models often have embeddings with significantly higher dimensions, typically ranging from hundreds to even thousands of dimensions. The choice of embedding dimensionality depends on the specific model architecture and the intended task. Larger dimensions typically allow for more nuanced and expressive representations of language, but also require more computing resources. In transformer models, both encoder and decoder blocks use attention layers in the multiple layers that make up the neural network for the model. These are important for processing text sequences. Attention quantifies the inter-token relationships. In the encoder, attention conceptualizes each token, so the same word can have different embeddings in different contexts. For example, chase, as in JP Morgan Chase Bank, versus chase a mouse. In the decoder, attention helps predict the next token by weighing the significance of preceding tokens. The model uses the attention layer to assign weights to each token. Usually, though, a technique known as multi-head attention calculates several scores, and an iterative process builds the output sequence token by token. Okay, so we know that AI mimics human actions, using machine learning to autonomously interact and perform tasks. Well, generative AI generates new content, often integrated into chat apps, like, for example, ChatGPT. These applications process natural language inputs and generate responses in text, images, or code. Azure OpenAI Service is for using and hosting large language models, combining OpenAI's advanced models with Azure's security and scalability. Microsoft's collaboration with OpenAI provides Azure OpenAI users access to the latest language model developments. Models vary in speed, cost, and task-specific performance. Models can be deployed as is or fine-tuned with custom data, and developers can work with these models in Azure AI Studio, a web-based environment for deploying, testing, and managing large language models that support generative AI app development on Azure. Okay, so what kind of model support is there in Azure AI Studio? Well, there's GPT-4. These are advanced generative models for natural language and code completion. GPT 3.5 models have similar capabilities to GPT-4, and GPT 3.5 Turbo is optimized for chat interactions and general AI scenarios. There's embeddings, which convert text into numeric vectors for language analytics, like text comparison, and DALL-E. This is the set of image generation models currently in preview mode in Azure OpenAI Studio. Copilots have emerged from advancements in large language models, acting as digital helpers integrated within various applications. These helpers have the potential to significantly enhance productivity and creativity in business through AI-generated content. For example, helping with tasks like creating drafts, synthesizing information, strategic planning, and so much more. They share a common standard architecture, allowing developers to create business-specific copilots. They can appear in familiar products, using content from the products to inform responses. For example, Microsoft Copilot teams up with Microsoft's Bing search engine to produce natural language answers to questions based on context instead of just presenting search results of indexed pages. Developing a Copilot involves training large language models with extensive data, utilizing services like Azure OpenAI Service for pre-trained models used as is or fine-tuned, deploying these models for application integration, and then building copilots that use model prompts to generate content. AI response quality is influenced by both the model and the prompts. Prompt engineering improves prompt quality for better outcomes. Clear, high-quality prompts are crucial in directing generative AI's actions, ensuring that it understands the desired task. System messages, for example, set the tone and limitations of the AI's responses, like instructing it to be a professional and helpful assistant. Also, for the best results, prompts should be specific and straightforward, such as asking for 10 benefits of using Azure AI Studio. Large language models can perform tasks without prior examples. This is zero-shot learning, but can also adapt to styles from example-based prompts, called one-shot learning. Then there's grounding data. This includes relevant data within prompts to enhance AI outputs, which is similar to fine-tuning. This video explores the generative AI tools and services on Azure and how they can be used to deploy and experiment with generative models. Azure offers a variety of generative AI tools and services that cater to different aspects of application development and deployment. The tools and services I'll mention are among the most significant and widely used for generative AI on Azure, notable for their capabilities and integration within the Azure ecosystem. They comprise a broad ecosystem of generative AI resources available on Azure, which continues to grow and evolve, offering powerful capabilities for a wide array of applications. The Azure OpenAI service provides access to advanced large language models like GPT-4. This enables the creation of applications with capabilities in natural language processing, content generation, chatbots, and language translation. Azure OpenAI Service is known for its flexibility and allows for the generation of high-quality text and images, revolutionizing user experiences. AI Studio is a comprehensive development hub for generative AI. It integrates various tools like Visual Studio, Power Apps, software development kits, Visual Studio App Center, and includes Azure Monitor, Azure Load Testing, and Azure deployment environments. These tools provide a robust environment for building, managing, and delivering cloud applications using various programming languages and platforms. Azure AI Generative Package for Python. This package is part of the Azure AI SDK for Python. It supports Python 3.7 and later versions, and it includes functionalities for building, evaluating, and deploying generative AI applications. Azure Cognitive Search has been rebranded as Azure AI Search. This change reflects the integration of more advanced AI capabilities into the search service, enhancing its ability to provide secure information retrieval at scale over user-owned content in traditional and conversational search applications. Azure Machine Learning is a cloud-based platform for building, training, and deploying machine learning models. It offers a range of tools for automating machine learning pipelines, managing data sets, and monitoring model performance. Azure Machine Learning supports various machine learning frameworks, making it versatile for different AI projects. Azure Databricks provides an Apache Spark-based analytics platform optimized for Azure. It's a powerful tool for big data processing and machine learning. It allows for collaborative programming in Python, Scala, SQL, and R, making it suitable for a wide range of data science and analytics projects. The Azure Bot Service is ideal for developers building conversational AI. The service offers tools to build, test, deploy, and manage intelligent bots. It can be integrated with various services like Microsoft Teams, Skype, Slack, and many other platforms, and facilitates the creation of interactive and intelligent chatbots for various applications. Azure Cognitive Services. So these are a set of APIs, software development kits, and services available to developers to enhance their applications with AI capabilities like computer vision, text analytics, speech recognition, and more. It's suitable for integrating AI capabilities without deep expertise in AI. Okay, next, Azure Kubernetes Service, or AKS. AKS is a managed container orchestration service using Kubernetes. It simplifies the deployment, management, and scaling of containerized applications, ideal for developers and IT professionals working with microservices and large-scale deployments. Azure Logic Apps is a service that provides a visual design interface for designing and building scalable solutions for app integration, data integration, system integration, enterprise application integration, and business-to-business communication. Azure Functions is a serverless compute service for running event-triggered code. It eliminates the need to explicitly provision or manage infrastructure and is ideal for developing scalable, efficient applications with a serverless architecture. Azure OpenAI Service offers an array of knowledge resources for learning generative AI while working on their platform. It includes quick starts and tutorials, and Microsoft provides comprehensive documentation for in-depth study and implementation, and covers essential topics like natural language processing, AI model generation, and responsible AI practices. Azure AI Studio has expanded its model catalog to include new models like Phi 2, Orca 2, and others. The new models range from small language models to diffusion-based text-to-image generation models and code completion models, catering to a wide range of generative AI applications. In this demo, we'll explore how to manage OpenAI-based generative AI models on Microsoft Azure Cloud Platform. Okay, to get started in my demo, I've opened my browser and I have 3 different tabs open. To work with Microsoft Azure, you need a Microsoft Azure account. So on the first tab, I've navigated to azure.microsoft.com. Here, you can select Try Azure for free to open a free account if your organization doesn't already have an Azure account. Okay, on the second tab, I've navigated to portal.azure.com, and this is where you'll sign in once you have your Azure account. Now, on a third tab, I've navigated to learn.microsoft.com/en-us/AI-services/OpenAI. Now, in order to fully take advantage as a developer, your user needs to be assigned the Azure Cognitive Services contributor role. So that's why I've navigated to this URL. Now, in the left menu, expand How To, expand Service Management, scroll down and select Role-Based Access Control. Now, if you scroll down the page, you'll find a summary table listing all the permissions for the different roles. So there's the Cognitive Services OpenAI user role, the Cognitive Services OpenAI contributor role, and then there's the broader-based Cognitive Services contributor role. So that's the role that I have. Now, if you have the Cognitive Services Usages Reader role as well, then you can also access quotas. Finally, I just want to remind you that in order to gain access to the OpenAI service on Azure, you need to apply to get access. I've opened a new tab. Now I'll navigate to aka.ms/OAI apply. And this redirects you to the Request Access to Azure OpenAI service page. The application process involves demonstrating well-defined use cases and a commitment to incorporating mitigations against potential misuse. If you follow the detailed instructions, then you should get an answer within a few days. So now back to my Portal tab. Now we need to create an Azure OpenAI service resource in order to use the Azure OpenAI service. Now under Azure Services in the Recent Services list, I've got Azure OpenAI already listed. However,
If you go to the search bar, just type in OpenAI, and that reveals the Azure OpenAI service as well. So if you select the Azure OpenAI service, that opens the Azure OpenAI service blade. Now I'm going to create a new Azure OpenAI service, so I'll select Create. Now under Project Details, I'm going to leave the pay-as-you-go subscription selected. Now for Resource Group, I'm going to create a new one, so I'll select Create New. Now it's a good idea to name the resource group according to a naming convention that you can use consistently. For this demo, I'm going to name my resource group RG-GenAI-Demos. Now I'll select OK. For the region, I'm going to expand the list, and I'm going to choose Canada East. And I'm choosing Canada East because it's one of the regions that supports GPT-4. And I want to use the latest GPT-4 models when possible. Now we have to provide a name for the resource. I'm going to name mine OpenAI-Service-CA-East. Now for the pricing tier, I'll expand the list. I'll select Standard S0. Scrolling down, make note of the Detect and Mitigate Harmful Use notification, and select Next. Okay, so we can leave the network at its default, which means that all networks, including the internet, can access this resource. I'll select Next. We won't specify any tags at this time. I'll select Next again. Now Azure runs a final validation. Everything appears to be good, so I'll select Create. Okay, so now Azure goes and provisions and deploys our OpenAI service resource. Okay, and a notification appears indicating that the deployment succeeded. Now, I'll select Go to Resource. Okay, and this takes me to my Azure OpenAI Resource Overview blade. Now, under Resource Management, make note of keys and endpoint. Later on in these demos, when you use the API, you'll need one of these API keys, and you'll need the service endpoint. Okay, but now we're going to go to Model Deployments. So I'll select Model Deployments in the left menu. Now I'll select Manage Deployments. And that brings me to the Deployments blade in Azure OpenAI Studio. Now I'll select Create New Deployment. In the Deploy Model dialog that appears under Select a Model, I'll expand the list, and I'll choose GPT-4. For a model version, I'll leave Auto Update to default. And then for deployment name, I'm going to just name this deployment GPT-4-Base. Now if I expand Advanced Options, I can specify content filters. I don't have any defined, so I won't be able to do that. Deployment type, I'll leave Standard selected. Now for tokens, it indicates that I've got 30,000 tokens per minute quota available for my deployment, and that's way more than sufficient for any demos that we're going to be doing. I'll leave the Enable Dynamic Quota setting enabled, and I'll select Create. Okay, and now a notification appears indicating that we've successfully created our deployment. Okay, so now at this point, we've successfully created an Azure OpenAI service resource, and we've deployed a GPT-4 model to that resource. This video explores generative AI models and how they're used in Azure. Azure Cloud offers a range of AI services and products that use various generative AI models and techniques. There are offerings like Azure OpenAI Service and Azure OpenAI Studio that provide access to the latest models like GPT-4 and DALL-E, ideal for advanced language and image generation tasks. Azure also provides a wide array of machine learning tools, computational resources, storage solutions, and other resources that together make up a comprehensive environment for developing and deploying applications that leverage advanced generative AI models. Okay, let's start with the most popular and common generative pre-trained transformer GPT models. These models leverage the transformer architecture to generate human-like text. These models are trained on an extensive corpus of data and excel in producing coherent and context-aware language outputs. Within Azure Cloud, they're used for chatbots, automated content creation, translation, sentiment analysis, and many other tasks. The key advantage of GPT models lies in their ability to replicate natural language, enhancing user interactions. However, they do have challenges like high computational demands, data privacy concerns, and potential biases in training data. OpenAI's most publicized and widely used models, including the GPT series and DALL-E, primarily rely on transformer architecture, and Azure Cloud offers a feature-rich environment for deploying GPT models, balancing advanced capabilities with effective management, making it the ideal platform for leveraging these sophisticated AI tools in various applications. Okay, recurrent neural networks and autoregressive models. So recurrent neural networks, RNNs, and autoregressive models are indispensable for processing sequential data. RNNs are adept at tasks like language translation and speech recognition, while autoregressive models excel in forecasting and signal processing. These techniques are key in text generation, financial trend prediction, and predictive maintenance, offering valuable insights from historical data patterns. On Azure, these models can be developed and deployed using Azure Machine Learning, with its GPU-based computing and tools like Azure Notebooks. This enables efficient training and application of RNN and autoregressive models in practical, scalable AI solutions. While OpenAI has developed and utilized RNNs in the past, and the Transformer series of models could be considered autoregressive models for text generation, its more recent and prominent generative models have clearly moved towards transformer architectures, which are more powerful for handling long-range dependencies in data. However, RNN and autoregressive models have been foundational in understanding sequential data generation and are still used across the industry for various tasks where sequential data is prominent. Generative adversarial networks are innovative AI algorithms consisting of two neural networks competing to improve each other, excelling in generating realistic synthetic data. In media and art, GANs are used for creating lifelike images, enhancing visual content, and artistic creation, showcasing their versatility and creativity. Azure Cloud supports GAN development with Azure Machine Learning, providing the necessary computational resources and scalability. This makes it ideal for the computationally intensive tasks of GANs, allowing for efficient training, deployment, and management of GAN models. Variational autoencoders, or VAEs, are a class of generative models that generate new data that resembles the input data, like images or text. At their core, VAEs work by compressing input data into a compact representation called the latent space, and then reconstructing the original data from this compressed form. This process involves two main components: an encoder that learns to compress the data, and a decoder that learns to construct the data from the compressed form. VAEs are valuable for a wide range of applications, from image synthesis and enhancement to anomaly detection. Okay, so let's talk about best practices for implementation. Effectively utilizing Azure's infrastructure for generative AI means leveraging its scalability, security, and efficiency. Azure's robust cloud services can scale resources dynamically based on demand, ensuring optimal performance for any AI application. Security is always paramount, and Azure provides advanced security features to protect data and models. Efficiency can be enhanced by leveraging Azure AI-optimized virtual machines and GPUs, which are specifically designed for high-performance computing tasks. Additionally, Azure's suite of tools for monitoring and automation helps maintain efficiency and minimize downtime. Azure's ability to handle complex AI tasks can provide businesses with the tools to innovate and improve their services using generative AI. For example, a healthcare company could use Azure AI's capabilities to develop a generative model that predicts patient outcomes, improving treatment plans and patient care. Another example is a retail giant leveraging Azure's cloud computing power to deploy a generative AI model for personalized customer recommendations, significantly enhancing customer engagement and sales. When deploying generative AI models on Azure, managing and optimizing resources is key for cost-effective and efficient operations. Azure offers tools like Azure Cost Management and Azure Advisor, which provide insights into resource utilization and cost optimization opportunities. It's also crucial to select the right type and size of Azure resource based on the specific needs of the AI model to avoid over-provisioning. Implementing auto-scaling and choosing region-specific deployments can help in this effort to be efficient and reduce costs. And regularly monitoring and adjusting resource allocation helps in maintaining an optimal balance between performance and expense, ensuring the most efficient use of Azure's capabilities for generative AI workloads. In this demo, we'll explore how to enhance the performance of generative AI models using prompt engineering with few-shot examples. All right, to get started in my demo, I've navigated to portal.azure.com and I'm on my portal homepage. Now I have some resources under Recent on my homepage. For example, the Azure OpenAI service that I've been working with recently. So I'll select OpenAI-Service-CA-East, and that brings me to the overview blade of the Azure OpenAI service. Now I'll right-click, go to Azure OpenAI Studio, and I'll select Open Link in New Tab. Okay, now over to the New tab. Azure OpenAI Studio provides playgrounds which allow us to experiment with deployed models without having to build our own client applications. Once everything is configured and working as we want, then we can confidently develop our own client applications. Studio offers different playgrounds with varying parameter tuning options. Now the chat playground is a conversational interface. Its associated chat completions API is designed for multi-turn conversations, so we, as developers, can send a series of messages as input and receive a model-generated message as output. This API is optimized for interactive applications like chatbots or virtual assistants that require a back-and-forth dialogue. We'll come back to this shortly. The completions playground and associated completions API, on the other hand, is designed for single-turn tasks where a prompt is provided and the model generates a completion based on that prompt. It's more suited for tasks that require a direct response without the need for prior context or conversation history. Then we have the DALL-E playground, which allows us to describe an image we want to create in natural language, and the model will go and create it for us. Next, we have the assistance playground. This allows us to experiment with, prototype, and test AI assistants without requiring us to run any code. It's a relatively new feature of Azure OpenAI service. Now, the management features allow us to manage models, deployments, customizations, and learning resources. In deployments, this is where we manage deployments. And these are essentially the endpoints of the Azure OpenAI base models or any fine-tuned models we've created. Okay, now models. Azure OpenAI offers models with varying capabilities and costs. Models lists the base models and also provides us with the ability to create custom models. The data files feature is where we manage testing and training datasets. We can upload our training and validation datasets to customize models to our particular use case. In Azure OpenAI, each model type is allotted its own quota covering all versions of that model. We assign quota to a deployment when we create it, but we can also edit the deployment after it's created. And quotas just lists the different quotas for the different models. And content filters. So content filtering is a system designed to identify and manage potentially harmful content generated by AI models. We'll have a chance to work with most of these features as we make progress through this journey. So let's go back to the chat completions playground. Now on the right side of the page, in the configuration pane, we have the model deployment that's being used. That's GPT-4-base. Past messages included helps give the model context for new user queries. And the current token count lets us keep an eye on the current token count to make sure that we don't exceed the max response token count. Now, under the Parameters tab, max response sets a limit on the number of tokens per model response. Adjusting temperature is a randomness setting that identifies how predictable or imaginative the responses are. Lower temperature setting leads to more consistent expected outcomes, while higher temperature settings encourage creativity. Top P is similar to temperature and controls randomness, but uses a different method. Lowering top P narrows the model's token selection to likelier tokens. Increasing top P lets the model choose from tokens with both high and low likelihood. It's recommended to modify either temperature or top P, but not both at the same time. Stop sequence tells the model the desired point that we want it to end its response. When set, the model response ends before the sequence specified, so the response won't include the stop sequence text. Frequency penalty reduces the repetition of tokens based on their previous occurrences, and presence penalty discourages reusing any previously mentioned tokens, which has the effect of increasing the chances of new topics being introduced in a response. Current token count is viewable here as well. Now, since API calls are priced by token, and it's possible to set a max response token limit, it helps us to keep an eye on the current token count. Okay, now let's go over to Setup. Under the Prompt tab, there's an information box indicating how we can use templates. So I'm going to close the box. I'm going to expand Select a Template, and I'll choose the Xbox Customer Support Agent template. Now in the Update System Message dialog that appears, I'll select Continue. Now I'm going to expand the system message. So the system message allows us to give the model specific instructions regarding its behavior and provide context that it should refer to when generating a response. For example, we can use this message to describe the assistant's personality, how it should format responses, or even tell it what it should and shouldn't answer. And this system message does all those things. Okay, now below that we have examples. We can add examples to demonstrate to the AI model the types of responses that we're looking for. Using these examples, the model tries to mimic the responses we specify. This also means that the examples should reflect what we specified in the system message. So the template comes with one example, and that is how much is a PS5, and then below that, the assistant says, I apologize, but I do not have information about the prices of other gaming devices. Now, we could select Add and add another one, but what I've actually done is I've saved my configuration, and we'll get to that shortly. Now, at the top, there's an Add Your Data tab, and this feature allows us to import our own business-specific data to enhance the chatbot's responses with more relevant and tailored information. We'll explore how to add your own data later in this course. Now, at the top right of the chat playground, notice the two options, Import Setup and Export Setup. If I select Export Setup, that brings up a dialog box where I can choose the file name, and it's a JSON formatted file, and I can specify to include the system messages, the few shot examples, and the parameters. Now I'll cancel out of here because I've already done that. Now I'll select Import Setup, and I'll import the system message, few shot examples, and parameters that I've already saved. I'll select Browse for a file, and in the Open dialog, I'll choose Chat Setup.json, select Open, then I'll select Load File in the Load Chat Assistant Setup dialog, and now that's done. Notice that I now have a second example. How do I power cycle my Xbox from Power Center after upgrading the system? And below, I specified the assistant answer that I'm looking for. And notice how I specify a step-by-step answer. Hopefully, with this type of setup, the AI model will respond accordingly. Okay, so let's try it. Over in the chat pane, I'll type a new user query. I'll ask, how do I upgrade my system? Press enter, and it responds with elaborate step-by-step instructions on how to upgrade the Xbox system. Okay, so with that then, we've successfully enhanced the performance of generative AI models using prompt engineering with few-shot examples. In this demo, we'll integrate business data with generative AI. Okay, to get started in this demo, I've signed into portal.azure.com and I'm on my portal homepage. Under Recent Resources, I'm going to choose my Azure OpenAI resource named OpenAI-Service-CA-East, and that brings me to the overview blade for the Azure OpenAI service. At the top of the page, I'll right-click Go to Azure OpenAI Studio, and I'll select Open Link in New Tab. Okay, and a new tab opens to Azure OpenAI Studio. In Studio, I'll select Bring Your Own Data tile, and in the Add Data dialog that appears, I'll expand Select Data Source. I have a number of options. I can choose an Azure AI search source, a blob storage source, Cosmos DB, Elasticsearch, a URL, web address, or I can upload a file. I'll upload a file for this demo, so I'll select Upload Files. Now that opens some new fields. I'll leave the subscription as Pay As You Go. Under Select Azure Blob Storage Resource, I could choose an existing resource But what I'm going to do is I'm going to create a new one. So I'll select Create a new Azure Blob Storage Resource. And that opens a new tab to the Create a Storage Account page. Under Basics, for Resource Group, I'll expand the list and I'll choose my RG-GenAI-Demos resource group. Under Instance Details, for Storage Account name, I'll just name the storage account Blob Store ABC123. Okay, and that's a unique name. And now region, I'll leave East US selected. Scrolling down, for performance, I'll leave standard, which is recommended for most scenarios. For redundancy, I'll leave the default geo-redundant storage selected, and I'll select next. And now this provides me with some advanced options that I can specify, including security, hierarchical namespace, access protocols, blob storage, and Azure Files options. I'll leave the defaults and I'll select next. Now, networking, I'll leave Enable Public Access from all networks selected, and under Network Routing, I'll leave Microsoft Network Routing selected. I'll choose Next. Now for data protection options, I'll leave the default settings and select Next. Now for encryption, I'll leave the encryption type set at Microsoft Managed Keys. Enable support for customer managed keys, I'll specify blobs and files only. That's the default setting, and I'll select Next. Now I won't specify any tags at this time. I'll select Next. That takes me to the Review and Create page, where Azure validates my settings. Everything appears good, so I'll select Create. And now Azure provisions and deploys the resources as specified. Okay, and now when that's done, I'll go back to the original tab, Chat Playground. Beside the Select Azure Blob Storage Resource dropdown, I'll choose the refresh icon. Then I'll expand the list and I'll choose the blob storage that I just created, Blob Store ABC123. And now a new notification appears indicating that we need to turn on cores. This is necessary in order for Azure OpenAI to access the storage account. So we need to turn on cores or cross-origin resource sharing. So I'll select Turn on Cores. Okay, and now under Select Azure AI Search Resource, I'll select Create a new Azure AI Search Resource. That opens a new tab to create a search service. I'll leave the default subscription. Under Resource Group, I'll expand the list and I'll choose my RG-GenAI-Demos resource group. Now for the service name, I'll just name mine Azure Search ABC123. Okay, that's unique. I'll leave the location West US 2 selected, and for pricing tier, I'll leave standard selected. I'll select Next, Scale, and this page provides some scaling options. I'll leave the default selected, but keep in mind that this can be pretty pricey. So you may want to delete this resource when we're done with the demo. I'll choose Next Networking. For endpoint connectivity, the default is public. I'll leave that as is. I'll select Next Tags. I won't specify any tags. I'll select Next Review and Create. Azure does the validation. It succeeds, so I'll select Create. So now Azure goes and provisions and deploys AI search service for me. Okay, now when that's done, I'll go back to the original Chat Playground tab. Now besides Select Azure AI Search Resource, I'll hit the refresh icon. Now I'll expand the list and I'll choose my Azure Search ABC123 AI Search Resource. Now I also need to provide an index name, and to be consistent, I'll name it Index ABC123. All right, and those are all the settings that I can change. Now I'll select Next. And now I need to upload the files that I'm going to use. I'll select Browse for a file, and in the open dialog that appears, I'll choose the Skillsoft White Paper 6 Elements of Effective Compliance Training. And I'll select Open. Now I'll select Upload Files. Done. Now I'll select Next. For search type, I only have the option of keywords, so I'll leave that selected. I'll leave the default chunk size, and I'll choose Next. Now review and finish, everything looks good. I'll select Save and Close. Okay, now under Setup in the Chat Playground, a progress box appears indicating that ingestion is in progress. It starts pre-processing. Then when pre-processing is done, it starts to do the indexing. And then when index is complete, the corpus of data is ready to be used. So now I can just submit a prompt to generate a completion. And from this page, we can quickly iterate and experiment with its capabilities. So what I'm going to do is I'm going to ask it, what are the 6 elements of effective compliance training? And this results in an excellent, relevant answer with references from the PDF data file that we uploaded. Okay, now, as mentioned, at this point, you may want to go back to the resource group and delete the resources that were created. Okay then, so at this point, we have successfully integrated business data with generative AI, and we tested it in Chat Playground. This video is focused on analyzing generative AI. We'll start by exploring how to analyze generative AI models. Analyzing generative AI models within Azure involves several steps, including model evaluation, monitoring, and the application of the models in real-world scenarios. Azure AI Studio supports both manual and automated approaches for evaluating large language models. Automated measurement is useful for measuring at a large scale and for ongoing measurement to monitor for any regression as the system usage and mitigations evolve. AI Studio supports 2 main methods for automated measurement of generative AI applications: traditional machine learning metrics and AI-assisted metrics. For a thorough assessment of generative AI applications, we can initiate an evaluation using Azure AI Studio and the SDK. This evaluation run provides us with comprehensive insights into the application's capabilities and performance. Being able to monitor models in production is a key component in the overall AI lifecycle. Azure Machine Learning model monitoring for generative AI applications makes it easier for us to maintain the quality and safety of our generative AI applications. Capabilities and integrations include collecting production data using Model Data Collector and responsible AI evaluation metrics like groundedness. Application Insights, part of Azure Monitor, helps us understand how people use our applications and the application's performance. This helps us to make data-driven decisions regarding development cycles based on users' behavior and application usage patterns. Generative AI models can be applied in various scenarios. For instance, Azure OpenAI Service can be used to generate customer-specific AI-generated review summaries. It also powers predictive analytics, which helps present businesses with a comprehensive view of future trends, risks, and opportunities. Another application is transforming text into video using Azure OpenAI and cognitive services. This involves key phrase extraction, image generation, audio synthesis, and video creation. Azure AI Studio can be used to create custom copilots. It also offers templates for crafting prompts and supports fine-tuning AI models. Analyzing the results produced by generative AI within Azure involves several steps, including data collection, data processing, and data analysis. Azure provides both traditional and AI-based tools and services for this very purpose. Azure AI Search is significant for its AI-powered capabilities like key phrase extraction, language detection, optical character recognition or OCR, image analysis, and translation. Its main role is enhancing search experiences and building AI applications that rely on the search experience. Azure Machine Learning supports data-driven decision-making by providing insights using historical data. We can build predictive models using Azure Machine Learning to improve accuracy in decision-making. This involves data preparation, model training, tuning the hyperparameters, and model deployment. Azure AI Studio is a single AI platform to build, evaluate, and deploy generative AI solutions and custom copilots. It provides a unified analytics platform that brings together all the data and analytics tools that organizations need. Azure AI Content Safety is a state-of-the-art AI system that helps organizations keep AI-generated content safe and create responsible AI applications. Now, reporting in Azure. Depending on specific needs, We can choose from several options for analysis, visualizations, and reporting in Azure. This choice should be informed by the scale, complexity, and the specific requirements of your data analytics tasks. Generative AI models are very good at predictive analytics and forecasting. By analyzing historical data and identifying patterns, organizations can use generative AI algorithms to make accurate predictions and inform decisions, optimizing supply chain management and inventory forecasting, as well as demand planning. For business intelligence, we can leverage tools like Power BI and Azure Analysis Services to create interactive reports and dashboards. Business intelligence tools close the gap between data and decisions, allowing for easy-to-use reports and analytics that make real data-driven decisions possible. Azure Machine Learning's responsible AI features help inform business decisions through data-driven insights. It includes tools for understanding causal effects and generating responsible AI scorecards to share model and data insights with stakeholders. In this demo, we'll automate the generation of a knowledge base for a corpus of data using generative AI and Azure AI Search to improve efficiency and productivity. Okay, so in this demo, we're going to integrate Azure AI Search with a language resource. AI Search will ingest the information source that we specify and automatically generate a knowledge base of question and answer pairs, alternate questions, follow-up prompts, and other information that would normally take days or weeks or even longer. In this demo, we'll use the PDF of a quick start guide for online learners for the source material. We'll ultimately use the knowledge base for a custom question answering bot that will answer users' questions over our data corpus. The knowledge base is stored in an Azure AI Search index in our own subscription. To get started, I've signed into Azure Portal. I'm on the Portal homepage. Now we'll create a language service resource. So under Azure Services, I'll select Create a Resource. In the search field, I'll type language. In the list, language service appears. I'll select language service, and I'll expand Create on the language service tile, and I'll select language service. So now this brings me to a select additional features page. And note that there are several built-in capabilities with language service, including sentiment analysis, key phrase extraction, pre-built question answering, conversational language understanding, and more. On this page, I'll choose Select in the Custom Question Answering tile, and then I'll select Continue to create your resource. On the Create Language page for Basics, I'll leave the subscription at Pay As You Go, and for Resource Group, I'll select Create New, and I'll specify a new resource group. I'll name this one RG-QA-Demos, and I'll choose OK. For region, I'll leave East US selected. For name, I'll name this resource Lang-QA-Demo. For pricing tier, I'll select the standard pricing tier. Scrolling down under Custom Question Answering, for Azure Search region, I'll leave East US selected again. For Azure Search pricing tier, I'll expand the list and I'll choose Basic. Under Responsible AI Notice, I'll check the Responsible AI Notice checkbox. Then I'll select Next. We're not going to do anything with the networking, so I'll just skip by network and select Next. For identity, we'll leave Enable System Assigned Identity to grant the resource access to existing resources and select Next. I won't specify any tags, I'll just select Next. On the Review and Create page, Azure does the validation. Everything seems fine, so I'll select Create. Now Azure goes and provisions and deploys the resources for us. And when it's done, I'll select Go to Resource Group. I have two resources. I have a language resource and a search service. I'll select the language resource. On the overview blade for the language resource, I'll scroll down, and under Language Studio, I'll select Get Started with Language Studio. That opens a new tab in Language Studio. In the Select an Azure Resource dialog that appears for Azure subscription, I'll expand the list and choose Pay As You Go. For resource type, I'll leave language selected. I'll expand the Select Your Resource field under resource name, and right now, our language resource isn't showing up. Now, after waiting a couple of minutes, select the refresh icon, then expand the list again, and yes, it appears. Okay, so I'll select the lang-qa-demo resource and I'll select done. Okay, and now on the Language Studio page, I'll select Understand Questions in Conversational Language, and then I'll choose the Custom Question Answering tile. This brings us to the project page. I'll select Create New Project, and in the Create a Project dialog, for the language, I'll choose English. Then I'll select Next. Now for basic information, for a project name, I'll just name this project Custom QA. I won't specify a description at this time. The default answer when no answer is returned is currently no answer found. I'll leave that, that's the default. And I'll select Next. Okay, and now on the Review and Finish page, everything looks good. I'll select Create Project. Okay, and now the project is created for us. And on the project page, we're redirected to the Manage Sources blade. At the top of the screen, I'll select Add Source. I can choose from URL, File, or ChitChat. I'll choose Files. In the Add Files dialog, I'll select Add File, then I'll select Choose File. In the open dialog that appears, I'll choose the Percipio_QSG_for_learners PDF file, and I'll choose Open. Okay, and now for a source name, I'll just name this User Guide, and I'll select Add All. Okay, and now that source has been added. Now if I select Edit Knowledge Base in the project menu, we now have automatically generated a QA knowledge base on our corpus of data. And that knowledge base is stored in an Azure AI search index in our own subscription. All right, so at this point, we've automatically generated the knowledge base for a corpus of data using generative AI and Azure AI Search to improve efficiency and productivity. In this demo, we'll integrate a custom knowledge base from Azure Language Studio to an Azure AI bot resource to create a custom question answering chatbot. Okay, to get started, I've signed into Azure Portal. I'm on my Portal homepage. Now, the first thing that I'm going to do is go to Language Studio. There's a couple of ways that I can do that. In the Recent tab under Resources, I'll select the language resource called lang-qa-demo. That takes me to the overview blade for the language service. Now, if I scroll down, under Language Studio, I'll select Get Started with Language Studio. And this opens a new tab in Language Studio. Now, you could go directly into Language Studio by navigating to language.cognitive.azure.com and signing in with your Azure account. Notice that I have a project named Custom QA. I'll select the Custom QA project, and that opens the project page to the Manage Sources blade. Now, in the left menu, I'll select the Edit Knowledge Base icon, and that brings me to the Knowledge Base blade for this project. Previously, I had Azure AI Search ingest the information from a quick start guide and automatically generate this knowledge base of question-answer pairs, alternate questions, follow-up prompts, and other information. And this is something that would normally take days or weeks, or maybe even longer. Okay, so let's test this out. Under question-answer pairs, I'll select the test icon, and that brings up a test slider. So what I'll do is I'll ask, how do I add skills? And the answer comes back with a step-by-step format. Okay, so everything appears to be working. I'll close the test slider. Now, over in the left menu, I'll select the deploy icon. On the Deploy Knowledge Base blade, I'll select Deploy. In the Deploy This Project dialog, I'll select Deploy, and Azure deploys the Custom QA project. Now, notice in the main part of the screen, step 2, go to Azure to create a bot. So I'll select Create a Bot, and that brings me to the Azure portal and the custom deployment page. Now, under project details, I'll leave the subscription at pay as you go. For resource group, I'll expand the list and I'll choose RG-QA-demos. For the location, I'll leave East US. The Azure bot handle is populated automatically for us, so I'll leave that as is. Now, by default, it chooses the standard pricing tier. I'll leave that as is as well. And under Microsoft App ID, I'll leave the Create New User Assigned Managed Identity option selected, and I'll choose Next. Okay, now under Web App, the app name is populated automatically. The SDK language selection, I'll leave that at C#. For the App Service Plan, I'll select the Create New App Service Plan option. and scrolling down under App Settings, I now need the language resource key. So I'm going to go back to the original tab in the Azure portal. And again, I'm on the overview blade of the language resource. Now under Resource Management, I'll select Keys and Endpoint, and I'll select the Copy to Clipboard icon beside Key 1. Now I'll go back to the Custom Deployment tab. I'll paste the language resource key in. The language project name is populated by default. The language service endpoint host name is populated by default, as is the subscription ID, the resource group name, and the account name. I'll select Next. Now under Review and Create, Azure runs the final validation. Everything appears good, so I'll select Create. And now Azure provisions and deploys the resources for my custom QA chatbot. Okay, and when that's done, I'll select Go to Resource Group, and that opens the resource group's overview blade. Now, you might initially notice that the bot resource is missing from the resources in this resource group. That can sometimes take a couple minutes to appear. So up above in the toolbar, I'll select Refresh, and sure enough, the Azure bot appears. So I'll select the Azure bot, and that brings me to the Azure bot's overview blade. Now, under Settings, I'll select Test in Web Chat, and now I'll ask the same question. How do I add skills? And it comes back and provides me with the same 5-step answer. All right, so with that, we've integrated a custom knowledge base from Azure Language Studio to an Azure AI bot resource and created a custom question answering chatbot. This video is concerned with security considerations when using generative AI. Generative AI models, such as those used on Azure, have the potential to revolutionize various industries. However, they also present potential risks that need to be considered. These risks include misuse by malicious actors. Generative AI models can be exploited by malicious actors, leading to misuse of the technology. Generative AI models can also pose a risk to data privacy. Sensitive private or proprietary information can be entered into these models, potentially leading to data leaks. Without robust anonymization or redaction measures in place, sensitive data becomes part of the model's training data set, potentially resurfacing later. And furthermore, generative AI models generate text based on user inputs or prompts, meaning a prompt containing sensitive data can influence the generated content, potentially exposing this data. There's also a risk of intellectual property or IP leakage when using generative AI. The ease of use of web or app-based AI tools can inadvertently lead to the creation of another form of shadow IT, which can result in IP leaks. Generative AI models can be vulnerable to semantic vulnerabilities, like manipulating word embeddings in natural language processing, and biased outputs. So generative AI models can produce biased outputs based on the data that they're trained on. There are also ethical concerns related to the use of generative AI, such as the impact on jobs, vulnerable populations, and broader society. There are legal risks, like compliance violation, breach of contract, copyright infringement, and erroneous fraud alerts. Then there are hallucinations. This refers to generative AI models generating glaringly false information, which in itself is a new type of risk. To mitigate all these risks, it's important to develop a company-wide plan focusing on building trust in AI, managing the risks, and securing AI systems. Okay, so best practices for securing AI applications. As we've just discussed, generative AI models can pose a risk to data privacy. Sensitive, private, or proprietary information can be entered into these models, potentially leading to data leaks. However, Azure OpenAI service ensures that the prompts, those are the inputs, and completions, the outputs, embeddings, and training data are not available to other customers, OpenAI, or used to improve OpenAI models, Microsoft, or third-party products or services. The models, in fact, are stateless unless explicitly fine-tuned with our own training data. Robust encryption for data at rest and in transit, along with strict access controls, should also be implemented. Techniques like data anonymization and differential privacy can be used to protect user data. Okay, so generative AI models themselves can be exploited through semantic vulnerabilities like manipulating word embeddings and natural language processing. AI models should be protected with encryption and version control. Regular updates with security patches should also be applied to the models. The societal and ethical implications of AI must also be considered. Clear ethical guidelines should be developed to address the impact on jobs, vulnerable populations, and the broader society. Now, another best practice is maintaining explainability. So AI decision-making should be made transparent. This can help in understanding how the AI system is making decisions and can help in identifying any potential security issues. Maintaining a version history of AI models allows for quick rollbacks in case of model compromises or failures. Another best practice is regular red team testing. Red team exercises should be conducted regularly to simulate real-world attacks and test the robustness of the AI system's security. Now, the important authentication and authorization process. With respect to authentication, one of the most secure methods is to leverage managed roles in Microsoft Entra ID, which is Azure's cloud-based identity and access management service. Also, to support straightforward secret rotation, each Azure AI service resource has 2 API keys. Key rotation is a very important security precaution, effectively allowing us to regularly change the keys that can access our Azure resources. And finally, AI content safety features. Azure AI content safety includes features like jailbreak risk detection and protected material detection. These features are designed to mitigate risks when using generative AI models. Jailbreak risk detection scans text for the risk of a jailbreak attack on a large language model, and protected material detection scans AI-generated text for known text content, such as song lyrics, articles, recipes, and selected web content. These features are part of Azure AI Content Safety's broader suite of tools, whose goal is to detect harmful user-generated and AI-generated content in applications and services, ensuring content safety across various scenarios. In this demo, we'll explore security protocols involved when working with generative AI. Okay, to get started in my demo, I've signed into Azure Portal, and on the first tab, I'm at the portal home. I have a couple of other tabs open. On a second tab, I have OpenAI Studio open, and on a third tab, I have Language Studio open. We'll explore those in a couple of minutes. First, under Recent, I've got a resource group named RG-GenAI-Demos. I'll select it to go to the overview blade for the resource group. It's important to understand that privacy and compliance are crucial when working with AI models, and of course, generative AI is no exception. One of the main reasons to work with Azure, and specifically the OpenAI models on Azure, is for the security in the Azure platform. So for example, regarding our prompts, completions, embeddings, and training data, they're not available to other customers or to OpenAI. They're also not used to improve OpenAI models, nor to improve any Microsoft or third-party products or services. In fact, AI models are stateless unless we explicitly fine-tune models with our training data, and even then, fine-tuned Azure OpenAI models are available exclusively for our use. Still, it's important to ensure that data used to fine-tune models does not contain any personally identifiable information or other sensitive data unless it's absolutely necessary and explicit permission is provided. It's just security best practice to perform data masking and de-identification to help protect sensitive data during the training process. A couple of other things. The Azure OpenAI service is fully controlled by Microsoft. Microsoft hosts the OpenAI models in Microsoft's Azure environment, and the service does not interact with any services operated by OpenAI, for example, ChatGPT or the OpenAI API. Azure OpenAI service provides built-in privacy features, including data encryption, because data stored in Azure is automatically encrypted using Azure Storage Service Encryption. One of the reasons I opened this resource group is because it's got a blob storage account included. So I'll select the blob store named blob store ABC123. On the storage account page, in the menu, I'll scroll down and I'll select encryption. So this section provides details about how the data in the storage account is encrypted. By default, Microsoft managed keys are used for encryption, but we can also configure it to use our own customer managed keys if we desire more control. With Microsoft managed keys, our data is encrypted with AES 256 encryption by default. Microsoft manages the keys for us. On the other hand, if we opt for customer managed keys, we'll specify a key from the Azure Key Vault. Also, it's important to understand that Azure encrypts data in transit. By default, it uses Transport Layer Security, or TLS, to protect our data when it's in transit. Azure also complies with global and industry-specific compliance standards like GDPR that may dictate encryption practices. Okay, back to the resource group. Okay, so another security feature that helps protect data and privacy is role-based access control. This allows for fine-grained access to resources, and we can apply this approach to different levels, including specific resource groups like I have open here. So a scenario might be that someone in Canada East may need to have access to the resource group that I've got open here, which is located also in Canada East. So over in the menu, I'll select Access Control, and this is where we can grant access to this resource. We can view access, we can view deny assignments, we can check our own access, and we can even create a custom role. I'll select Add Role Assignment, and there are a number of job function roles. Now if I search for cognitive, scroll down, and locate the Cognitive Services OpenAI user and contributor roles. So for example, contributor has full access, including the ability to fine-tune, deploy, and generate text, whereas user has the ability to view files, models, and deployments, and can call inference operations. So depending on the role, for example, a developer may require a contributor role, whereas regular users may only need to call inference operations. So totally different roles, and that's what role-based access control is for. Okay, now over to OpenAI Studio. So here in OpenAI Studio, another security measure is content filters. So I'll select Content Filters, and I'll select Create Customized Content Filter. So the Azure OpenAI service uses a content filtering system that works by running both prompts and completions through a collection of classification models. The objective is to detect and prevent the generation of harmful content. The content filtering system detects and acts on certain categories of potentially harmful content. This includes hate, sexual, self-harm, and violence categories. So the models used for content filtering have been trained and tested on some languages. These include English, German, Japanese, Spanish, French, Italian, Portuguese, and Chinese. The service can still work in many other languages, but the quality may vary to some degree. Microsoft, however, recommends that in all cases, we should perform our own testing to ensure that content filtering works as we expect it to. Okay, so now over in Language Studio, I have this custom question answering project named Custom QA. In this project, I integrated Azure AI Search with a language resource. Search ingests some information that we specify, so in this case, in the form of a PDF. And Azure AI Search and the language resource automatically generate a knowledge base of question and answer pairs. The data is encrypted at rest, but not only at rest. When the grounded information is being used, it's also encrypted in transit. All right, and so with that, we've explored some security protocols involved when working with generative AI. In this demo, we'll explore some of the measures that we can take when troubleshooting generative AI. Okay, so consider this hypothetical scenario. We have a number of users complaining about degraded performance of an application that uses a deployed GPT-4 model. The model is deployed under the OpenAI-Service-CA-East Azure OpenAI resource, and that resource just happens to be under Recent on my portal homepage. So I'll select the OpenAI-Service-CA-East Azure OpenAI resource. That opens to the overview blade. Now in the left menu, I'll scroll down and I'll select Support and Troubleshooting. And under How Can We Help You, in the Briefly Describe the Issue field, I'll type Deployed model takes forever to answer basic requests. And I'll select Go. And that will come back with some additional prompts. Which services are we having an issue with? Cognitive services, that's correct. We won't change that. Which resource? Yes, it's the OpenAI-service-CA-East resource. Now scrolling down, are you having one of the following issues? And the issue we're having is availability and service quality, poor performance. So I'll select the availability and service quality option, scroll down, and select Next. And now it comes back with some suggestions. I'm pretty sure it's not pricing and model availability. Otherwise, we'd be seeing explicit errors. Scrolling down a little bit, it starts talking about tokens. And how does OpenAI count token? So this gives us some hints as to what might be going on. Okay, so let's go back to the home page. And what I'll do now is I'll open Cloud Shell. So in the toolbar, I'll select the Cloud Shell icon to open Cloud Shell. Down in the taskbar, I'll select the Visual Studio Code icon to bring up Visual Studio Code. And here I have a CORL command. And I'm going to use the CORL command to make a request to my service endpoint. I specified the content type on line 2, the API key on line 3, and the body of the request, starting on line 4, which includes the messages to send to the AI model, the maximum tokens, temperature, frequency penalty, presence penalty, top P, and stop sequence. So in the editor, I'll highlight the entire CORL command, press Ctrl-C to copy. Now I'll go back to my browser where I have Cloud Shell open, and I'll right-click and select Paste to paste the command in. I'll press Enter. Okay, and it comes back, and there aren't any specific problems showing up yet. So let's clear the screen. Now right-click and paste the same command in, press Enter to run it, and now we see a 429 error. So in the context of an app employing Azure Generative AI models, a 429 error tells us that an application has exceeded the rate limits imposed by the Azure service for API requests. A 429 error can result from exceeding tokens per minute limitations set on a deployed model in Azure's generative AI services. So these token limitations are a specific form of rate limiting that governs how much text in terms of tokens an application can send or receive from an AI model within a given minute. Okay, let's minimize Cloud Shell. Now I'll select the OpenAI-service-CA-East Azure OpenAI resource. I'll right-click, go to Azure OpenAI Studio, and I'll select Open Link in New Tab. And OpenAI Studio opens in a new tab. So now what I'll do is I'll go into the chat playground, and just for good measure, let's type a user query here. I'll type, what are the limitations of AI? Press Enter. Okay, so it comes back with an answer fairly quickly, and there are no errors involved. Let's ask another question right away. We'll ask, are there researchers trying to address this? Okay, and here we go. We see that we've now exceeded the token rate limit of our current pricing tier. If we go to deployments, so under management, I'll select deployments. With the GPT-4 base deployment selected, I'll select edit deployment. In the edit deployment dialog that appears, I'll expand advanced options, and the tokens per minute rate limit is set at 1,000. I'm going to move the slider to 10,000. I'm also going to enable dynamic quota, and now I'll select Save and Close. Okay, so now let's go back to the chat playground, and let's start over. So I'll select Clear Chat, and in the Clear Chat dialog that appears, I'll select Clear. Now let's try that same query again. What are the limitations of AI? All right, and it responds with a similar answer as it gave before. This time, there are no errors. So we were able to perform a couple of steps to troubleshoot and determine that we were up against the token per minute rate limit for the AI model deployment. All right. Well, with that, we were able to successfully diagnose and resolve issues related to generative AI models on Azure Cloud.
So in this course, we've examined how generative AI can be used for IT administrative integration. We did this by exploring generative AI concepts, tools, techniques, workflows, and automation. We analyzed generative AI, models, optimization, and performance improvement of AI models. We explored security considerations using generative AI, as well as protocols and troubleshooting applications that use generative AI. In our next course, we'll move on to explore advanced generative AI application techniques to improve the reliability and scalability of IT systems.